Okay, hello guys, how are you? Now we're going to talk about how context switch happens in the operating system. The idea of context switch is to enable us to switch between processes even though one process did not finish. Even then, we can switch between processes by changing the context of how of where we are running the process, namely changing between processes. This is what is called a context switch, changing between which processes are ran by the CPU. So let's start and see what happens. This is an animation of a context switch. We start with a CPU that executing process 2. Each process has its unique program counter, which tells the CPU where to run the process, where is the process in the memory, and where to run the process. You can see that each process has program counter that tells where the process in the CPU registers for this process, like the stack pointer and the pace pointer, the process status word, and the memory management info. Now, those are the things that we save in what is called the process control block that saves all this data for a specific process. Each process has its own PCB, process control block, that tells the CPU, for example, where is the program counter of this process, where the process is in the memory. So again, we have the P2, the process 2 in the CPU. Now, we want to do a context switch. There is interruption. So what are we doing? We save the data for the current process we are in, process 2 in its PCB, and we can move to another process using his PCB, his program counter and everything. We load the PCB of the process we want to work with, for example 3, to the CPU, and then the CPU can run this process. We change from process 2 to process 3, even though it may be that process 2 didn't finish. There was an interruption, for example, that told that we need to move from process 2 to process 3, like may happen in round robin scheduling. For example, if process 2 finished his time in the CPU even though he didn't finish. So we are saving in the PCB of process 2 all the data, including where the process is, where the program counter, and we move to another process, to process 3 in this case, using process 3 uh, PCBs that has all the data for where is the process and etc. And again, now process 3 is running. There is an interruption and we need to change the process. So again, we take again the PCB of the process and load it to the CPU so the CPU can move from process 3 to process 1 and run it. This is the idea of the context switch, how the CPU can change between processes even if those processes didn't finish. We can save their PCB, know where to return if we want to return in the future, then take another process PCB and run this process. You can see that in the future, we'll go again to process 2. We already been there, but how do we know where to go back to? This is based on the PCB that saves where the program counter, where in the process we are at exactly. The program counter is moving on each order in this process, but it tells me in process 2 where are we. That's how the CPU knows where to get back to, where he gets back to the process, where in process 2 to start, to continue. We don't need to start from the beginning. We start from where we stopped when we last left this process. This is thanks to the PCB with the program counter that tells where we were when we stopped. And that's how we can continue and run this process again. Again, we are in process 2 and we can execute it and we can continue from where we stopped thanks to the PCB and thanks to the program counter. And this is it. You can see it running just automatically, taking the context switch off a process. This how knows how to run it. Save the process to PCB, all the program counter and everything, and taking another process and running from where we stopped, using again is PCB, and this is how we context switch. We switch between processes and running each of them. And there is interruption between them, so this is the signal for doing a process and context switch. Thank you very much, and this was about context switch on the CPU for different processes. If there are any mistakes or corrections, please tell me. Thank you very much, and I think this is it. That's it.